This is Mr. Beck Does Your Homework. This is AP Physics Homework 3.1 about balanced forces. So far in your homework, you did a simple up and down question. You did a question with a force at an angle that you had to split up into vertical and horizontal. And we also did a down the ramp problem where we had to change our axes to up and down the ramp and in and out of the ramp. Well, this question is, a machine in an ice factory is capable of exerting 3.37 times 10 to the second newtons of force to pull large blocks of ice up a slope. The blocks each weigh 1.4 times 10 to the fourth newtons. Assuming there is no friction, what is the maximum angle that the slope can make with the horizontal if the machine is to be able to complete the task? Wow, what a great question. So, I've got a ramp that these things are sliding up. I have a block of ice. I have no friction, but I have the machine that can apply a force this way, and that force is going to be 3.37 times 10 to the 2 newtons. So that's my 3.37, slide down a little bit, times 10 to the 2 newtons. The blocks each weigh 1.4 times 10 to the 4th newtons. So that is, the weight is the force of gravity. So the force of gravity is the weight. Is 1.4 times 10 to the 4th newtons. Assuming there is no friction, what is the maximum angle that the slope can make with the horizontal? So I want this angle where somehow this is all going to work out. Well, let's look at a free body diagram. I've got force of gravity straight down. I have this pull force up this way. Any other forces? Sure, I must have a normal force perpendicular to the surface. I know that somehow I want to get to the point where all of these balance because I want the component, some component of the weight to equal this amount. So I want the machine just to be able to pull this stuff up at a big angle. Now, if I take a look at this, I've got gravity straight down. Well, gravity straight down has to be split into the axes of the ramp, and the ramp has an up and down the ramp and an in and out of the ramp. Those are my axes, not x and y, but up and down, in and out instead. So I want gravity to be split into a component into the ramp and a component down the ramp. So this is going to be Fg into the ramp, pushing into the ramp, and this one's going to be Fg down the ramp. Now, when this is in balance, when this is in equilibrium, I know that this component must equal this component. So if I redraw my free body diagram with components, then I've got a normal force this way. I've got a pull force this way. And when I split up gravity into into the slope and down the slope, then this will be my force of gravity into the slope, and this will be my force of gravity down the slope. So I know that at equilibrium, this pull must equal this force of gravity. Now, they've already given you the force is 1.4 times 10 to the 4th newtons. So if this is Fg, how do I get Fg down? Well, here is the angle that is equivalent to this angle, because as this gets smaller, this angle would also get smaller. As this angle gets bigger, this angle would also get bigger. This angle equals this angle. So I know that if I can find this angle, I can find this angle. I know that my component of gravity down the slope is going to be my overall force of gravity. Down the slope is opposite that angle, so it's going to be times the sine of theta. And this g sine theta should remind you of when we did frictionless down an incline, the acceleration was g sine theta. So my force of gravity is going to be mass times acceleration, so that's going to be mg sine theta. But I already have the force of gravity, so it's just going to be this weight times the sine of theta is my force of gravity, and I want to set that equal to this pull force. So, to get the force of gravity down, it's the force of gravity, that's the weight. That's going to be 1.4 times 10 to the 4th newtons times the sine of the angle that I'm looking for is going to equal my pull force, 3.37 times 10 to the 2. How do I solve this? Well, let me divide by that. So now I know that the sine of the angle is going to equal 3.37 times 10 to the 2 divided by 1.4 times 10 to the 4th. This is going to give me some number. That's the sine of theta. So theta is going to be the inverse sine, the angle whose sine is these two numbers, 3.37 times 10 to the 2 divided by 1.4 times 10 to the 4th. And that will give me my angle that I'm looking